Hello everyone and welcome to EvolkAI, a machine learning community for machine learning enthusiasts. Now today we will be dealing with Ridge Classifier CV, where CV stands for cross validation. So Ridge Classifier CV is a variant of Ridge Classifier that includes built-in cross validation CV to automatically determine the best regularization parameter. To understand it, let's continue with our friend's analogy. Imagine each of your friends has a different level of expertise in accessing job applicants. Some friends might be very experienced and have a better understanding of qualities need for job, while other might be less experienced. The rich classifier CV algorithm takes this into account. It evaluates the performance of rich classifier with different regularization parameters, which controls the balance between fitting the training data well and avoiding overfitting. The regularization parameter determines the level of influence each friend has in final prediction. Instead of manually choosing a single regularization parameter, the rich classifier CV automatically searches for the best one through cross validation. Cross validation involves splitting the available data into multiple subsets or folds. The algorithm trains and evaluates the rich classifier on different combinations of these subsets to find the regularization parameter that performs the best on average across the folds. The main difference between rich classifier and rich classifier CV is that latter takes care of finding the optimal regularization parameter for you. It simplifies the process by automatically searching and selecting the best parameter through cross validation, which helps to avoid the need of manual parameter tuning. Okay, so now moving to the practical part. Okay, so now first we will start by importing the pandas library, and we will read the dataset using the read CSV function, and we will get all the data information using the info function. Then we will assign all the columns that we have to take from the user and store it in features variable, and the prediction class will be predicting column will be stored in prediction class variable. So and their values will be stored in x, and for the features, and for prediction class the values will be stored in y. X will have all the data that our user will give us as the input, and y that it will get as output from the machine learning model. Now this is the training and testing part. Here we have to train here we have to split the data into training and testing part. So here we have assigned test size as 0.30, which is an ideal, as we have already discussed in our earlier videos, that the testing part should always be less and training part should always be more. So here the training and testing part is divided into the ratio of 7 is to 3. That is 70% is the training part and 30% is the training part. More that a model will be trained, more accurately it will predict the results. Okay, so now here we will check the shapes of the data to check if the test split has done its work correctly or not. Okay, for now for model assigning, we will import rich classifier CV from linear model library, and we will assign this model to CLF variable. Now we will fit this data with the training part, that is X train and Y train, and using this model we will predict on X test and store the output in the Y print. Now after this we will import metrics from sklearn, and by using ytest and ypred variables, we will predict the accuracy on this model. Now, for every time ytest and ypred are same, the accuracy will increase, and the other times the accuracy will decrease. Okay, so the accuracy we have achieved here is 86.6, which is okay. Now, let me just take you to the VS code, so where I can explain you what we have done till now. Okay, so now we have come to our Visual Studios. Now we'll just quickly run all these code snippets. Now first we will import pandas library as we have done before in all the coding tutorials. Now we will read the dataset using read CSV function and read the iris dataset. Now using .info function we will get all the information related to the data set, like how many entries are there, what are the column names, and what are the data types, if the value has, if not non-null values are present or not, their memory usage. Now we will define two lists, that is features and prediction class. So features will have all the column names that will be used as input, and prediction class will have all the column names that will be used as output. Now their respective values will be stored in x and y, like features value will be stored in x, and prediction classes value will be stored in y. So for different sets of features, a particular y will be predicted by the model. Okay, now we will split the data into training and testing part using train test split, and using these x test shape we will calculate their shapes if the splitting has been done properly or not. Now from sklearn.linear model we will import a rich classifier CV. So Ridge Classifier CV is a modified version of Ridge Classifier with another cross validation functionality added. So cross validation functionality just increases the number of iterations. So when the much bigger accuracy comes, it predicts the maximum accuracy received. So now we will fit this model with the training data, and when the data is trained, we will predict the data on X test using the model, and will store the data in Vibrate. Now from using sklearn.metrics, we will import accuracy score, and we will predict the accuracy based on Y test and Vibrate. Now, for every time y test and y print being same, the accuracy will increase. Otherwise, the accuracy will decrease. So this was it for the rich classifier cross validation. Now we will be moving to the conclusion part, and will conclude the video. Okay, so now we have reached the conclusion part. So by telling you all this information, I can say that rich classifier CV eliminates the need of manual tuning and enhances the performance of classifier. The advantages of rich classifier CV include its ability to handle multicollinearity, providing interpretable results, and its automated selection of regularization parameter. It is computationally efficient and can handle high-dimensional data. However, rich classifier CV shares the same limitation as rich classifier. It assumes linearity between the feature and the decision boundary, which may limit its performance in capturing complex nonlinear relationships. It may not perform well in cases of severe class imbalance or high nonlinear decision boundaries. Despite their limitations, the rich classifier CV is a valuable tool when dealing with datasets where multicollinearity is a concern, as it automatically selects the regularization parameter to imbalance model complexity and performance. So this was pretty much it for rich classifier CV. I hope you like the video. Please क्या है